Here today with Scott, founder of Deepgram. We have some really exciting news that we're going to be talking about today, but I'm Brooke. I'm the founder of Global. We do simulation and evaluation for voice agents, and Deepgram started off in transcription, but now builds all sorts of different voice models for every layer of the stack. Anything to add?
Well, yeah, thanks for having me on. And we've been at this now for 10 years as a company. We brought end-to-end deep learning to the speech world a long time ago. And now the voice AI is mainstream, so everything is taking off. And so it's an exciting time.
Yeah, we were just talking about how VapiCon previously would have been a very niche, probably group of people that were interested in voice AI and voice models, and now is becoming even more mainstream. And we'll probably look back and think, wow, that was like just the beginning at where voice will eventually go.
Yeah, you can tell when it starts to become mainstream because your investors are asking for tickets to it and that type of thing. You're like, what? You never cared about any of these voice events before. Now you do.
It's also sometimes hard to tell how much of it is you're so deep in it to like constantly surrounded by all of these different models. I used IVR on a call with an investor, and then they were like, oh, what's IVR? And it just occurred to me that that's like PPO, IVR, like TTS, SDT, VAD are probably not terms that everyone is used to hearing, but now they actually do know them, which is really cool.
Yeah, they're still all paying their tuition, in this area, but very quickly, over the last year. Yeah.
VapiCon tomorrow, and you guys are announcing a very exciting new model. I would love to hear from your words, like, what are you announcing, and kind of what are you most excited about?
Yeah, so we are announcing a new model tomorrow, and the problem that like our team was addressing is this trade-off between latency and interruptions. So I would say like probably one of the biggest problems in voice agents today is interruptions. The reason for that is people are trying to like crank down their end of thought models or something like that so that there isn't a lot of latency. So there's like this trade-off between latency and interruptions that is kind of fundamental. And if your model only looks at the text output, or if it only looks at silence, or if it's only like a VAD detector or something like that, then there are all these edge cases all over the place that make the system either wait too long or interrupt. And the new model that Deepgram is releasing is called Flux, and it's the naming, like the code name for it was River, but this is because it's like a new type of stream. But Flux is
awesome.
So new type of streaming. It's a streaming first model, built totally from the ground up. It's something that we've been working on for over 2 years, and like we knew it was coming, that voice agents needed this, but we wanted to do it right. We wanted to do it with super low latency, extremely fast, lots of throughput, but still have really high accuracy. So there's no accuracy trade-off whatsoever in Flux compared to our last models like Nova 3 or Nova 2. But the latency is drastically reduced, and then it includes things like an end of turn detector. So this is all coming in through the stream. So you don't have to if you don't want to set up another VAD or some other kind of end of thought detector. What people will be able to sign up and use tomorrow, when we announce it at VapiCon, so probably by the time you listen to this, it's already out, will be the Flux model. And actually, we're going to do something special for the month of October too for the release.
That's super exciting. Yeah, I got to try out the new Flux model, and it blew my mind. Like, I think that I've tried out a lot of new models, and sometimes it can be hard to tell the huge gains of models because voices already sound really realistic, and really you're looking at the long tail of things. But I think trying out Flux, it's just immediately apparent just how fast it is, how good the end of turn is. So actually, we added it to benchmarks, and we allow you to now play around with these different models to benchmark them yourself live, real time. And even playing around with that, it's just immediately apparent how fast it is, how much better it is at detecting like the context. I know you said that you don't yet have context in it, but I think already just being able to have both the turn detection and the transcription happening at once dramatically improves it.
Yeah. Flux is the first step in the way that we think of the world, which is our Neuroplex architecture. So Flux is like the first piece to it, which is providing more context to the entire conversation. And Neuroplex is a white paper that we put out maybe 6 months ago, something like that describes a system that is a lot like the human brain, where you have specialized regions in your brain that are there for motor control, for speech, for spatial considerations, etc. And that's all calculated in your gray matter, which is kind of like the outside of your brain. But then there's a whole bunch of connected tissue, which is the white matter in your brain that connects all these different pieces together. And so if you were to think of like a standard cascaded system right now, it would be like only operating in your gray matter or something, and they're not like talking to each other through your white matter. And so part of the problem there is the only way that you can pass context is through text streams then. So you have like speech to text coming in, and audio coming in, and speech to text coming out, and then you just have this text coming out, and that doesn't convey all of the information about what's coming in. Whose turn is it? What language are they speaking? Are they excited? Are they not? Are they speaking quickly, slowly? Whatever it is, all this extra information is sort of flattened out and gone. But in the Neuroplex architecture, that's not like that. That will be taken care of, and each stage, like the equivalent of speech to text, the equivalent of an LLM, and the equivalent of text to speech will have context flowing through it. It'll accept context, it'll output context. Each stage also will have like a good, better, best, so you can kind of scale up how fast or how good you want it to be, or how cheap you need it to be, or something like that. And Flux is just like the first model that we released that's in that architecture.
Yeah. Well, it's really interesting because I think this is actually really similar to how self-driving systems have evolved. So there are lots of chain models together, which is why it makes it so similar to what's happening with voice, where you have, perception of what's happening in the world around me. What do I think everyone is going to do next?
Yep.
VAD. What should I then say next? Planning.
Yep.
And then how do I actually say that? Controls or text to speech. And all of these models are also non-deterministic, also working in parallel to be autonomous. But it's also interesting because I think you're arriving at a very similar architecture to self-driving, where you have it's not that one model passes something to the next model, but they're actually all publishing messages to then other models can subscribe to.
Yep.
And I think this model of, the human brain is one model, but also just PubSub of everyone being able to say, like, what do I think is happening in the world? What do I think is happening in the world? And then everyone can decide to, do I care about empathy? Do I care about like tone? Do I care about background noise? So for example, with self-driving, you might have sirens and audio, but if you're deciding, how fast or slow to go to brake, you don't really care about the audio.
Yep.
And so you can start to modulate like what things you even care about. And I think that's a really cool direction to be going in.
Yeah, I think robotics is just kind of in general, self-driving, all the work that has been done kind of makes it real and gives you ideas and pioneers a lot of the space already. So you can, like, if you're just looking for what a voice agent would do in real time, et cetera, then you can look at a lot of these systems. So, you've got the walking dog, like Unitree, Boston Dynamics, et cetera. The way that those systems work is, yes, there is something that is responding to the outside world, this perception layer, PubSub way of thinking, but then also there's an internal real-time computation that is like trying to keep the robot alive, basically. It's a separate like routine that's running, basically. So like if it's walking and trips a little bit or something, like it attends to that first. Like, no, I need to not fall. But I'll still be listening to what's coming in, like turn left or whatever. But the first thing I'm going to do is not fall, and then I'll turn left or whatever, right?
Yeah.
And so it's a similar kind of system that has to be built for voice agents too. Like you're getting all this input, CRM information is firing, all of this, et cetera. It's like, whoa, I need to be the good conversationalist here and continue the conversation while my background processes are running, and then I'll interject at the right time, et cetera. So it's a really good model for understanding voice AI, and also just that kind of like L1, L2, L3, L4, L5, way of thinking also is a really good model for voice agents as well.
Totally. Yeah, I think it's interesting. We're kind of at the stage of, I have a lot of people are just doing, I call text to speech, speech to text in sequence. And that's kind of the equivalent of just having like a servo like controlled by some Python. And I think that it's such a short path to the Boston Dynamics version, but there are so many things we have to solve, which is, I think, a lot of what you guys are solving, like how do we actually create fallbacks? How do we create UX that allows for that level of autonomy? I'm especially excited about Flux because I think something else that you're doing very similar to robotics is starting to combine certain models. So I think in self-driving, we saw this trend of, combining lots of models once we found out what makes sense, then separating them out again, then combining them and separating them out again. And I think this kind of pendulum swinging back and forth is a way that the industry really moves forward, because you're able to capture all of the signal while also having separation and responsibility. And I think Flux is really cool because the two pieces that people most often are combining today and having like disconnect between.
Yep. Yeah, there's like this like melt and condensation thing that just has to happen over and over, and you sort of rework it based on what data you have on hand, what are customers asking for, and like what technologies come up, what GPUs are available, what other like know-how has been discovered about getting these models to work really well. And so then you just like redo it again, and then now like maybe we'll fuse it this way, maybe we'll fuse it that way. And yeah, it sort of remains to be seen like what the final state of everything is going to be. Like end to end, sure, yes, like that is going to be a way of thinking about it, but like you can't get rid of tool use and agents. So like there is no end to end when you're talking about tool use or something. Like it isn't really how it works. Just like there's no end to end for humans operating in the world. There's an end to end for like deep learning way of thinking about how a human operates, where it's self-contained and whatnot. But what are we doing? We're interfacing with each other. We're picking up things in, in the environment, et cetera. So that's not end to end, So there's this like, everybody has to get comfortable with the fact that it's going to be a hybrid system all over the place, no matter what. It's just a question now of like, what do you combine and when, and that is determined by what your constraints are. Do you need to be faster? Do you need to be better, more accurate? Is more data available? Whatever it is, right? And the infrastructure providers will like respond and build those things, and then you'll have new capability.
And I think the really cool part about voice is that there are so many different use cases that there's actually no one right answer. It's like you might sometimes care, like turn detection might be really specific for your use case because you're working with different vocal patterns, because you're working with people who have like hard time speaking, or you're working with older people, or like these cases where a generalized solution might not work as well. Whereas there are other cases where I think actually having a full end-to-end solution maybe just is sufficient for your use case, because you have like a widget on your website that you just want to be able to do some quick chatting with. I think what you guys have done with combining the VAD and speech is really cool, because something that we've seen a lot from real time, people wanting real time, is being able to capture all of that signal. But then, as I think you've alluded to, you lose a lot of this controllability. And so I think real time definitely makes sense for some cases, but you don't have the controllability. And ultimately, I think if you're pushing the boundaries of what voice can do, it's going to be very hard to do that without having tool use, having these different use cases. When do you think it makes sense to consider real time versus how should people be thinking about their stack and architecting it as all of these models are becoming so much better?
I think that most AI actually will be real time in the future, and I'm talking 10 years from now. And whereas most, if you just want to think of this as like token count right now, like most token count is actually interactive mode or batch mode right now. And voice is like the first real-time use case, at least in the conversational world. So it's like there needs to be a big transformation essentially that's going to happen, and making real-time work really well, low latency, high accuracy, all of this. But I think real-time is actually just fundamentally different than the interactive mode of utilizing tools, because when you're using tools in interactive or batch mode, you can think in a totally different way, which is like bigger is better. The more parameters, the better. Cram as much data as you can into the model. Also, I don't care if it fails the first time, just try it again. That type of thing. It's a totally different mentality than the real-time mentality. Real-time mentality is like, no, I need super low latency. I need to always work. It's a totally different frame of reference. And I think everybody's okay with the interactive kind of lossy mode now, especially like in consumer use cases and in that area for now. But the demands are just going to keep going up and up. Like the demands on quality are going to keep going up and up. So I think we'll be talking in 2, 5, 10 years, and we'll be saying, oh my God, like 80% of AI is real time now. Websites are generated in real time. Everything I do is just like real time AI. It's running on my phone. It's running everywhere I am. And so I look at the world from that lens, and then I think, wow, there's so much more that needs to be built from an infrastructure perspective. There's so much more from a testing perspective, like what you guys are doing. And really, I think what's going to happen is, and we already see this with a lot of customers, where they're looking for infrastructure providers that are more like strategic infrastructure providers. They think of it more like, hey, I want to work with you because I know that you're going to build it the right way and do the right thing. And then that means I don't have to think about it. So it's kind of like, I'm going to partner with AWS, or I'm going to partner with GCP, or I'm going to partner with Azure for my compute, because then I don't have to think about it, And this is going to happen now in these real-time AI systems too, especially for voice, but like all over the place, you know? And so we always, like in Deepgram, we are always thinking about real time first, but I'll also be, you know, straight about that you can't always build everything in real time. It's not quite ready yet sometimes.
Yeah.
And so, for instance, like our Nova 3 models in Nova 2 and every other previous model in Deepgram is actually under the hood, is actually a batch model that has been formed and jammed, you know, to work in a real time way. But when you use it versus Flux, which is a from the ground up rewrite bidirectional streaming, you know, type model, that's a totally different kind of architecture, then you can feel the difference. Because I know in the playground that you just showed me, it's just like a drastic difference, right? You're seeing chunks of stuff come out kind of delayed and whatnot. And even though it's a fast model by today's standards, when you use Flux, you're like, oh my God, this is like completely different. It's because it's this real-time first like paradigm, basically.
Yeah. It is interesting because I think a lot of, especially on transcription and text-to-speech, a lot of the models have been repurposed from like a previous era where real-time wasn't as important. And it was a lot more about like post-processing of audio or being able to generate audio for movie clips or for media, etc. And now you're taking a lot of these models and using them for an entirely new use case. We've seen this even with benchmarks. Like all of the benchmarks previously were all for like for not real time, and so all of a sudden, you know, time to generating the transcript for an entire length of audio doesn't matter because you know, by the time you've generated it for the whole audio, the conversation's over. You're looking at what is like the real time factor. How fast are you generating the transcript in real time so you're responding to people? And I think all these things look very similar, but they're actually really fundamentally different. I think you've alluded to it a little bit, but where are you most excited in this forgot the word, Neuroplex?
Neuroplex, yeah.
Let me restart. I know you've alluded to it a little bit, but where are you most excited for in the Neuroplex of the future? Where are you kind of going next, or where do you think the industry is going to develop next after combining kind of speech and VAD?
The general roadmap for Neuroplex is you want to add, the way I think about it, at least talk about it internally, is multi-track for each of the different pieces, the sub pieces of the voice agent stack. So like for speech to text, that portion, the perception portion really, the text is one of the tracks, but like the turn detection is another track, and what language they're speaking is another track, etc. So you want to move to this like multi-track way of thinking, basically. But there's another piece to add on to that, which is like an other or an asterisk, or the best way to think about it from the way we think about it in the Neuroplex way is it's an embedding space, okay? And so so you have to move away from human interpretable if you want the full context to be passed along. So your perception models will accept all of those things that I just talked about, plus this sort of arbitrary open-ended embedding space as a function of time. And it will output all of those things in an embedding space. And then now, if you're wondering, like, how the hell is this going to work with an LLM? The LLMs have to be rewritten. LLMs right now, a lot of people don't know this. It's insane. We were just talking about real time. They generate in a streaming mode. That's true. They generate token by token, but they don't accept anything in the streaming mode. Like there's basically no bidirectional streaming LLM. So like that has to be invented. But even if I say a bidirectional streaming LLM, people would think, oh, you mean text in, text out streaming. Well, yes, I mean that. But I also mean all of the other tracks. You're like, oh, okay, so like the languages and this and that. Yeah, I mean that. But also the embedding spaces, you know? So it'll be accepting embedding spaces, it'll be outputting embedding spaces. And now if that, like, you know, bends some brains where you're like, how is that all going to work? It's going to be a mess. I'll just say but I look at this a lot like, you know, AWS started with like, I don't know, 13 options. And if you go look at AWS now, there's like a billion things that they offer, you know? Like it's kind of going to become a mess for a while.
You'll be on AWS for eternity.
Yeah, it's just going to kind of be a mess for a while, but then it's actually going to, you know, congeal back together again. And like, people will be talking in terms like, hey, I need my streaming embedding, you know, input here. You know, which streaming embedding model, you know, is it 128 elements? Is it 256? Is it whatever? Like, we're all going to have to learn this new vernacular, basically. And then you know, what we expect will happen is that every customer will start demanding those things out of every provider, basically, and then the whole stack is going to have to be, you know, revisited, basically, to get that full context in there with amazing tool use. So the next step is you build that into each of the individual components. So the perception, the understanding part, and then the generation part. And if you're sort of thinking about that from first principles, then you're like, well, actually, if you build them like that, then already it's essentially a speech-to-speech system, like a speech-to-speech system. Like it's giving full context throughout the entire system. But now it has those delineations, those like more clear, discrete gaps where humans, could sniff and interpret, and debug and say like, did this go right? Did it not? Can I shape the way that this agent is working by sort of biasing this part of the model or whatever? Which is very different than a full end-to-end speech-to-speech model where you have no idea what's going on. There's there's a black box. Yeah. So I'm excited about rolling those out. Flux is the first, entrant in that. Flux will be expanded as well to have even more multi-track capabilities and this sort of arbitrary embedding capability. But our TTS is we'll release a new version of that accepts that is more controllable, that you can change the speed at which people, the voices that are generated are speaking. You can put in silence. You can, all sorts of things. And then now, what about the missing LLM, piece? Deepgram is an LLM company. What? Deepgram is a transcription company. We're training our own conversationalist LLMs at Deepgram. So the way I look at it is we're not trying to build a know-it-all LLM. We're trying to build a conversationalist LLM. But it's going to be bidirectionally streaming. It's going to be multi-track. It's going to be working in this voice agent way. So it'll be purpose-built for that. And then if you're wondering, but then how do I get the know-it-all capabilities of the big models? You just use them as tools. So it's just tool use. Okay, go out and I need this model's opinion over here and over here. And then it's all working in the background, just like the robot that's, tripping or whatever that has it, like it's that underlying thing. Yeah, it's orchestrating it all. And so then, probably 80% of the tokens will be handled by that conversationalist model. And then it'll be, reaching out for assistance from other tools, discrete type tools or model type tools, et cetera. So yeah, it's really exciting. I think that is just the way the West will be won. Like that's how it should be built. And because it will be inspectable, debuggable, understandable, you can scale up each portion of it, to how much you want to spend or not, or, whatever it is. And so that's like what people need in order to build scaled voice products. So, yeah.
That's so cool. Because I think these are like the three big areas that we're seeing as like the biggest, I think the quietest and most dormant places in the market right now are on the on VAD and doing better turn detection. There just aren't that many options. Like if the turn detection isn't great, you don't have that many levers that you can pull. And then I think to your point on LLMs, I think LLMs are all trained on the internet and internet text, which is not at all how we speak. Yeah. And I think Notebook LLM did amazing things where they very clearly have tuned for a very specific style of speaking. And they did an amazing job with that. And so it's clear that you can do a great job of like styling for a specific pattern of speech. Obviously, podcasting is going to be a very different tone of speech than you're talking on the customer service line or you're trying to negotiate freight logistics. And so I think being able to train on speech, on phone calls, on speech patterns is going to be huge. And then the last one of like these novel voice architectures, I think that's something that we've seen I think what's really cool is we get to see all of the different voice architectures across the entire ecosystem, like you guys must. And I think people are definitely iterating a lot. But going back to what I said about self-driving, like I think there's still yet to be that self-driving model where you can truly have this controllability and orchestration, but also be able to really dramatically improve the level of autonomy, have like fallovers, have like redundancy, have that reliability that you need to actually put this in production.
Yeah, I want to get to the point where you can do all the things that you would do with a human to train them and do that same thing with a voice agent. And then you just trust that the agent is going to do it. And so what I mean is, what do you do with a human? Like when you hire them to do a job, you're like, you put out a job post with a JD and you say, here's like your job, right? But then when they come in, you give them all the training, for the company. Read this, read that, watch this video. Listen to if you're a call center agent, like listen to these calls. These are examples of when it went well. These are examples of when it didn't go well. Do this, don't do that, etc. And this is all very multimodal, right? But when a person does that, then now they go out into the world and it's like, okay, do your first calls or whatever, right? Then they get feedback and then they get better from it. And so like this idea of just kind of thinking of it like what would a human need? What would a human do? Or what would a human need to be excellent? So what are the training materials that we already have, et cetera? Like, boom, here you go. And we're a little ways off from that. Like just any product that has been built today to be able to do that, but I don't think we're that far off actually. And I think that as kind of a guiding light to building the product, it means that it'll speed the adoption really quickly, because you already have these things laying around. You already have JDs laying around. You already have training material. You already have all of that. So if you just build a product that can absorb those and then say, here, here's your voice agent. And then we all know that first voice agent is going to be perfect. It is not going to be perfect, just like a human wouldn't be when they were first put into that, right? But then now you need this evaluation and then an update. Here's how you should be better, et cetera. And then it's like, okay, well now I trust that system, right?
Yeah.
So yeah, I'm really excited about that. Yeah.
So that's actually really cool, because that's what we're already doing this, where we work with people to deploy voice agents, and we're using training materials from that already exist to make them better. I think this is something that we get a lot, is what happens when real time is perfect and you just don't need evaluation at all. It's very similar to, well, what happens when like humans are just good at every single job? Either that human's going to be really expensive if they can do any job in the world, or you're going to need to do training and need to tune it to what your business wants to do. And so I think that's what we really want to do with Koval, is how can we help you build this operating system where you can run a training be able to train, be able to use that to give feedback, be able to see how things are going in production.
Yeah, and is the world steady state? Nothing ever changes. There are new things don't happen, and you don't wonder like, I wonder how the agents are handling it now or whatever. Like, you have to know all of these things. So at the very least, it's just like a visibility framework. And so those systems are like, we design those for humans now, and even not all that well, because humans are kind of lossy in how they input their data and all of that stuff. But like, it's going to actually work even better for agents. So the need is going to be like even higher. Like the value of that market is probably going to be even higher, because the success is going to be so good. So yeah, it's I think if folks are kind of thinking you don't need it because everything is so perfect, like it may be 50 years from now, I don't know, but certainly not the next few decades. It's a crazy vision
of the world, When we have AGI, I actually don't know what any of us will be doing.
It's hard. Yeah, exactly. It's really hard to say, well, what if AGI just does everything better than everyone? I don't know.
That's a crazy world. I don't know what I'm going to. I'll be on an island. So
Yeah.
Awesome. Well, I'm so excited about this. I love your vision for a Neuroplex future, and it was awesome to have you here.
Yeah, thanks for having me. Appreciate it.